Hello everyone and welcome to Learn LEED Chapter 3. I'm Trey Hauk and today we're going to be talking about the where of buildings are located. We talked about it briefly in transportation and location, but this is really doing a deep dive on not just selecting the site, but ensuring that we are selecting a site that's going to be best for the environment. So as an overview, we're going to be going over site design and management, rainwater management, the heat island effect, and then last but not least, light pollution. So let's get started. Starting off, we have site design and management. So landscape design has a couple of tenets. When we're looking at good landscape design, it optimizes the use of the site. It's integrated with the local ecosystem, and it carefully considers the site's geology, topography, solar insolation, hydrology, and wind patterns. We're making sure that the building is oriented so that the sun can effectively, passively heat and light it. We're looking at minimizing impacts during construction and operation, and we're employing landscaping as an adjunct to the technical system. What we mean by that is that we're using the natural environment to support the built environment. And we'll go over a little bit more of what those two mean later on. But for now, let's move on to the approaches for green building landscapes. Land is one of the main resources needed for a green building. And we're looking at three main goals. We're going to try and use previously utilized land, preserve and protect wetlands and other uncontaminated green lands, and we're looking to reuse property and buildings if able. As it's one thing to demolish a lot and build something new on there, and it's another to just reuse the old building and retrofit it for what you need it for. From there, we're going to use native and adapted drought-tolerant plants, and we're looking to minimize earth moving and compaction. This is going to maintain the hydro period of the site, which is essentially the way that the water flows and water channels through the site. And we're looking to utilize the sun, wind, and foliage in a solar design to ensure that the building is not only being heated by active elements such as heaters and air conditioning, but also being heated and cooled by those natural elements. Now, native and adapted drought-tolerant plants is a process formerly referred to as xeriscaping, but that will be more into the water management chapter later on. For now, I'm going to move on to the loss of prime farmland, which, as defined by the USDA, is the land on which crops can be produced for the least cost with the least damage to the resource space. It has an adequate percentage of precipitation and nutrients and everything that we need to actually grow crops. Land committed to non-agricultural uses is not classified as prime farmland. I'll let you read the rest of that if you want to. I'll pause for a couple seconds just so you can read it. And moving on. So from there, we're going to move on to a couple statistics. From 2002 to 2012, 44 million acres of land were newly developed. That's a 59% increase from the past. In addition, from 1982 to 2007, we saw about 41 million acres of rural land being converted to developed uses. For comparison, that's the size of Illinois and New Jersey combined. And from 2002 to 2007, 7.5 million of those acres were converted. So we're seeing an increase in the amount being converted over time. Food increases the path to development. 91% of fruit and 78% of vegetables are produced in urban influenced areas. And the issue isn't that we're expanding development, it's just that we're wastefully using the land and not efficiently optimizing its usage. From 1982 to 2007, the US population grew by 30%, while our developed land increased by 57%. That's about a 27% difference from what it should be. You see, Redirecting development away from prime farmland is addressed in the U.S. Green Building Council LEED New Construction and Green Globe Building Assessment Standards each. And they both utilize the preservation of valuable resources during this process. So it's important that we preserve this prime farmland. As after all, this prime farmland are what we call greenfields. They're properties that have experienced little or no impact from human development activities. And in order to create a high performance land, we really want to recycle to help reuse the natural land that was once used for human activities. Some examples of greenfields are, in addition to that farmland, we're talking forest land, unused land parcels, and we usually find these located outside or on the edge of a city. We don't really find them on the inside. Parks can also be a part of this, but we're really looking at the land that's been, for the most part, hands off, untouched. Then we have brownfields, which are abandoned, underused industrial and commercial facilities. And most of the brownfields are developed land that isn't currently in use. It could be potentially contaminated. There's another category for that type of land, subcategory, but most of the time what can cause brownfields to occur is when hazardous waste appears and when buildings are abandoned. Some examples are abandoned factories, landfills, dry cleaning establishments, and gas stations. The most common contaminants that cause these sites are hydrocarbon spillages, solvents, pesticides, and heavy metals, essentially things that seep into the soil and generally hurt the ability for life to be sustained from that parcel of land. From there, we have gray fields, which are a subsect of brownfields, and this is a less contaminated building, essentially just a blighted or obsolete building that has been abandoned. These are urban properties that were underperforming or declining in value for technological, economic, or social reasons. So, for example, when we saw the transition from proper mall buildings to strip malls, we saw a lot of abandoned malls that, while necessarily not contaminating the land below them, were still abandoned and unused. Some examples that make these buildings obsolete are they could lack a fire suppression system. There could be abandoned boarded up housing, or there could be septic systems and old fuel tanks that just aren't cutting the job anymore. With that though, we then get to the darker side of brownfields, otherwise known as blackfields. These are properties that are not only abandoned, but are also found in heavy industrial areas. A common example are coal mines. The surface water in these zones have a very low acidity and are contaminated with iron, aluminum, sulfates, and other pollutants that make living here very hazardous for individuals and make it very hard for natural life to sustain itself. Again, it's still an expanded definition of brownfields, but by utilizing a black field specifically, there's a potential for obtaining additional LEED new construction credits by building projects here. So from there, we've talked about the land itself, but another important thing about the land is rainwater management, as unless you live like in the dry desert, chances are your property is going to be experiencing some rain. And what we do with that rain is crucial to sustainability. So first things first, for those people who receive lots of rain, we have to prepare for 100-year flood zones, which according to FEMA are essentially zones wherein a 1 in 100 chance of a flood has a chance of taking place. Now, obviously, it isn't just 1% per year. It's just the average of how often we see these catastrophic floods. FEMA has a bit more of a map for the flood hazard boundaries, and this kind of helps to influence flood insurance and the response maps themselves. So when we're looking at this, we're looking at a special flood hazard area. This is an area of land that would be inundated by a flood, having that 1% chance of occurring in any given year based off of that 100-year period. And if there's a structure within this special flood hazard area, it has a 26% chance of flood damage within a 30-year mortgage. Talk about a return on investment. So in order to earn points as a green building, when attempting to certify, just because we don't want this building just getting flood damage and then becoming abandoned, the building site must be at least 5 feet above that 100-year floodplain. It ensures that we're protecting it long after the mortgage has been paid off and ensuring that people can continue to use it even through natural disaster. From there, we have to talk about threatened and endangered species. The 1973 Endangered Species Act. It regulates a wide range of activities affecting plants and animals designed as endangered or threatened. So, an endangered species is an animal or plant listed by regulation as being in danger of extinction. Then we have threatened species where they aren't quite endangered, but they're on that slippery slope downwards. For endangered species, we talk about critical habitats, which are habitats required for the survival and recovery of a particular species. If an endangered species doesn't have the habitat it needs to grow and function, then chances are it's going to become an extinct species. Now, for the provisions of the Act to occur, it does have to be specifically listed in the Federal Register as endangered or threatened for the provisions of the Act to apply. Now, what the Endangered Species Act does is it prohibits the importing or exporting of the specified species from the United States. It possesses the selling, delivering, carrying, transporting, or shipping of any such species unlawfully taken from the United States or on the high seas. And we are also prohibiting the transporting of it to other countries, either for own purposes or for selling. It also provides protections for critical habitats and the creation of a recovery plan for each of the species that it lists. As of January 2016, the U.S. Fish and Wildlife Service reported that there are about 692 species of animals, 894 species of plants, and 84 species of plants and animals proposed for listing. LEED and Green Globes both do not provide credit if the project site is on land identified as a habitat for species that are on state or federal lists of threatened or endangered species. Going on from there, we have soil erosion and sediment control. And in order to have a high performance of green buildings, care must be taken in order to ensure that soil loss is minimized. Construction managers and subcontractors must pay attention to soil loss in the form of airborne dust and stormwater runoff. Thus, a erosion and sedimentation control plan is a prerequisite for certification under new construction LEED, which means that the plan is required for the building to even be considered for the lowest level of certification. Obviously, a building is only as good as its foundations, and if the soil is running off due to improper stormwater management, then it doesn't even solve its purpose of being sustainable. Now, what are the principles for preventing this? Well, we want to design the project to fit the site's context, its topography, its soils, its drainage patterns, and natural vegetation. We want to try to disrupt the natural flow as much as possible. That means limiting the removal of vegetative cover, keeping viable topsoil for reuse once the landscape is installed, and reducing the duration of excavation so that we don't have to impact and disturb that natural topography. So landscapes, they used to be an afterthought and were never really given a high priority with earlier versions of LEED 1 through 3. When the budget got tight, the landscape was often one of the first things to get cut. However, sustainable landscapes can assist with heating and cooling and controlling stormwater to prevent that erosion and to eliminate costly stormwater infrastructure such as gutters and canals and drainages. Not only that, they treat waste and provide food and help contribute to the local ecosystem, promoting biodiversity. So, landscapes that contribute to human well-being and at the same time are in harmony with the natural environment are ultimately what we consider sustainable landscapes. They don't deplete or damage other ecosystems, and while human activity has alter the native patterns, a sustainable landscape can still work with native conditions in its structure and functions. This mainly involves preserving valuable resources such as water, nutrients, soil, and as a result, we see a conservation of energy and the diversity of species being maintained and increased. This was started by John Tillman Lyle with a book published in 1985, The Design for Human Ecosystem, Landscape, Land Use, and Natural Resources. I haven't personally read it myself, but it is a recommended read from other people I've talked to in this environmentalist field if you do have the time to give it a once-over. From there, we have some ways of making the building itself be a part of the solution to stormwater and site management. And that is with green or living roofs. Essentially, it's a green roof, which is an updated version of a sod roof that is more commonly used in Europe. It's also called a living roof or an eco roof. It's meant to be low maintenance, drought tolerant, a self-seeding vegetated roof that requires little or no irrigation, fertilization, or maintenance. Obviously, people aren't going to be getting up onto the roofs to water the green grass. We're looking at incorporating native plants so that they can be independently functioning. And we ideally want to place them on low slope and pitched roofs with only approximately a 40% slope. We can get into more intensive eco-roof systems, such as actual roof gardens. These are more actively landscaped features, and you see them more on the top of condos and other buildings. And then from there, we also have the vertical garden, which utilizes these vertical surfaces to provide a framework for plants, which is also called a green wall. Now, some examples we have of this in their components are the plants, the soil mix, filter fabric, the water retention layer, the drainage layer, the root barrier, waterproof membrane, and insulation layer. Now, all of these layers stack up and provide quite a lot of weight for the building, so you normally see a concrete slab roof for this. And specific engineering considerations are needed so that you aren't collapsing the building in the process of trying to make it green. Now, by doing this and by developing the land, we, with concrete and asphalt and these other impervious materials, we cover the pervious grass and soil and sediment, which can increase the volume and velocity of horizontal water flows and can also modify and destroy an ecosystem as we're dramatically increasing the concentration of water flowing through a particular area. The primary function of a green building is to address this stormwater management issue and to have as little of an effect as possible on the site's natural hydro period or the flowing of water throughout it. Now, with stormwater management, we have a couple methods. We want to minimize the impact area, that is, minimizing the amount of surfaces we're covering in impervious materials. We're minimizing the amount these impervious areas are connected, and we're looking to prevent gutters and other things that would directly impact the flow of water from its natural cycle. In addition, we want porous paving, which kind of takes some of those impervious areas and changes it to more pervious ones. We have low maintenance landscaping or xeriscaping, and through that we're minimizing soil compaction and minimizing slope modification so that we know where the water is going to flow and where it's going to pool so that it isn't unnecessarily pooling in any other areas that could potentially destroy the built or unbuilt environment. This diagram here kind of goes to show you the distinction between impervious and pervious surfaces. Essentially, if the water can't go down, it will go through. And when we have these large concrete and asphalt areas, that can result in water damage to buildings. It can result in mold and mildew and flooding. But with pervious surfaces, we give that water an opportunity to go down instead of through. Now, obviously, there's going to always be some element of water going over the top. That's just how water works. But we can reduce it as much as possible by adhering to the natural landscape and ensuring that that water has a place to go rather than destroying our buildings. We call this low impact development, which integrates the ecological development systems with landscape design to manage stormwater runoff effectively. This creates green infrastructure, which are systems and practices of land development that use natural processes to infiltrate, evapotranspirate, or reuse stormwater runoff on the site where it's generated. Last but not least, the other keyword we have is artful rainwater design, which is an idea based on the premises that stormwater management techniques are designed in conjunction with natural systems that can provide site amenities with a strong aesthetic quality and even compel human interaction. Basically, just allowing the landscape to not only be environmentally friendly, but to become art and to, make the building look prettier. The 6 principles for embodying these 3 terms is to use existing and valuable features, to let the natural resources work for the project, to increase the value of the site with these open spaces, which in turn reduces the size of the water management needs on site. We want to treat stormwater close to the source, as smart landscaping can save us money. There's a couple more techniques here for this low impact design strategy. Just listing off a couple important ones. Tree preservation, rainwater collecting, rain gardens. Obviously, it's going to vary from place to place. For example, in Utah, they don't allow the collection of rainwater just as it's a desert, and the city wants to be sure that it's able to collect the water itself and manage it for the greater good as needed. You can pause it, read through these, but those are just a couple techniques. And by doing this, and by getting these green surfaces, not only do we manage stormwater, but we also prevent the heat island effect. Now, what is the heat island effect? Well, it is the gradual heating of an area by several or more degrees as green surfaces such as trees and grass are ultimately replaced by more reflective surfaces such as concrete, asphalt, buildings, anything that would be reflecting the heat that would normally be absorbed by the greenery. And it's why we see that temperatures in cities are substantially higher than those in surrounding rural areas. It's largely in part due to the heat island effect, or the urban island effect as it's also sometimes called. Now, in order to mitigate this, the United States Environmental Protection Agency has identified some additional negative energy impacts and problems from heat island effects. Not only do they contribute to global warming by increasing our fossil fuel consumption by power plants, as we have to fuel our air conditioners and climate control systems more, again, that positive feedback loop, it's also increasing ground level ozone pollution by increasing the reaction rate between nitrogen oxides and other volatile organic compounds on the ground. And with these increased temperatures, we see that human health is also affected, as we're more likely to have heat waves and other effects that directly hurt and harm people. Now, heat island effects can be reduced by several measures. We can start by installing highly reflective and emissive roofs that reflect solar energy back into the atmosphere. We can plant shade trees in your homes and buildings to reduce the surface and ambient air temperatures. And by using light-colored construction materials where possible, we are focusing on reflecting that light rather than the dark materials which would be absorbing and causing the building to heat up. Now, I have a diagram here that kind of shows you the impact of a urban heat island profile. And you can see that as we move from the rural to the more industrialized commercial and downtown, we gradually see the average afternoon temperature increase. So when we're reducing the heat island profile, this is what we're looking to reduce. There's one other type of pollution that we think of when it comes to site management, and this one is more about our night sky, light pollution. What is light pollution? Well, there's two versions. There's light trespass and light pollution. Light trespasses are lights that will illuminate their desired areas, but also illuminate off-site areas. This creates blinding reactions for both pedestrians and automobile drivers, and affects our overall health, as no one wants to be blinded as they're driving to and fro. Light pollution, on the other hand, focuses more on what's above us and prevents views of the night sky. If you've ever been out to the countryside where there's not a whole lot of natural lighting or man-made lighting, the night sky is absolutely beautiful. It's covered in stars, and we just don't see that in these more developed urban areas because of light pollution. So what's the solution to this? We want to look at the height, aim, distance, and last but not least, turn off the lights when we're not using them. This is kind of a example here. We have a street light that doesn't have the proper things put in place. So not only is it trespassing into the neighborhood homes, blinding people trying to sleep, it's also reflecting up into the sky and preventing those beautiful views that we like to see. So one last question for us to kind of think about before we move on to the next one, and that is, how does managing the site around the building promote better sustainability? I'm Trey Hauk, and this has been Learning LEED. Thank you.